So yes, last time we just created our this layout, okay, and we just tried to put the equipment at this particular location, correct? Now, what are we going to do is see, uh, equipment modeling is not about, or you can say piping is not about modeling the equipment and routing the pipe with the PNID. No, it's not that easy. Okay, so whenever you create an equipment now, so what are the things that you need to consider with the equipment is, suppose for example when you go for a job and someone gave you to, okay Gajendra, do one thing, this is the area number, you have to handle this, okay na. So in the layout also I mentioned you, whenever you are making a equipment layout and all those things, so you have to see, first of all you have to see the equipment size, the number of pipes connected to the equipment. Okay, so first of all you have to understand the size of equipment. Size of equipment means the length and dia, the length and dia, L and D. Okay, length and dia, you need to figure it out, how much is the height or length of the equipment. Length means if it is a horizontal it will call as length, if it is a vertical it will call as height. Okay, so length and height, length and dia of the equipment. The second point that you need to consider is number of pipes connected, number of pipes connected to equipment, right? Why am I'm saying this? Because this will give you the information about the number of nozzle. Now sometimes what happen now, when the vendor gives you the GA drawing, he might miss some of the nozzles. Okay, he might miss some of the nozzle, or he might give you extra nozzles which is not required as per the PNID. So you need to, yeah, so you need to comment on that particular document, so that I don't want this nozzle, or I want an extra nozzle at this particular location. Okay, so that is called as commenting on a vendor GA drawing. So number of pipes you have to identify. Then the third point that you need to identify is the biggest pipe, is the biggest pipe. Okay, now biggest pipe means you have to start routing that pipe first. You have to target that pipe first, because if you target the biggest pipe, you will come to know that how much area is going to be consumed surrounding the equipment, right? So the biggest pipe you need to identify, and then you have to go in ascending order. Okay, so first of all you have to, descending order, first of all you have to figure out the maximum size of the pipe, and then you have to go down, means the smallest one. So that you have to identify. Fourth point that you need to do when you are doing equipment piping is that you have to identify the surrounding. Identify the surrounding. Now what is the surrounding means? Surrounding means walkway the walkway, PLTF, platform. Okay, walkway and platform. Just a second. So walkway, you need to find out the surrounding, and you need to find out the maintenance area. Maintenance area. Okay, now maintenance area in a vessel or in a drum, what will be the maintenance area? Maintenance area will be always considered that area where the manhole is. Where the manhole is. So that will be the maintenance area. You got my point. So in that way you have to identify the whole surrounding of the equipment, correct? So what we are going to do is, see, we already learned about the length and dia of the equipment. Okay, length and dia will be initially given in PNID,
Hey, hello. How are you? Morning. Hey. Good morning.
right? Length and dia is initially given in PNID. My meeting is also started. How many people are there? Okay. Yeah, okay. No, no, it's fine, side. It's going on side by side. Okay, right. So size of equipment. So initially it is given in the PNID, correct? And in the PNID you will find the number of pipes connected to the equipment so that you can identify the number of nozzles required. If extra nozzle, you have to remove it. If nozzle is shortage, you have to tell the vendor to add the nozzle at this particular location. Then you have to identify the biggest pipe. So you have to start piping, do the piping of that particular pipe, and then you have to identify the surrounding. So today we are going to discuss about the identify the surrounding topic. Okay, so that is your walkway platform and maintenance area. So now let's work on that. Okay, so basically see, now what you need to understand here is, okay, so for example, this is my horizontal equipment, correct? This is my horizontal equipment. Yeah, like this. Okay, and similarly we will have it here also, like this, right? So I know that this is the center line of equipment, and I know that all the nozzle which is in perpendicular up direction, here like this and here like this, correct? All the nozzle is, or you have to provide access to all the nozzle. So the most important thing is that you have to provide, now under this 4 point you have a point A is provide access to all nozzle at every elevation, every elevation required, every elevation required, like above above 1.8 meter. So any nozzle which is above 1.8 meter need access. Now what do you mean by access? So access means operator hands should reach there. Means a person can easily, his hand can reach to the nozzle. Now what are the why it is required? Because in the nozzle, whenever you are going to connect your pipe in with the nozzle, you have to tighten with the bolts. Understood my point? So they, yeah, so there you need, there, that's what it does mean. It means access, providing access to every nozzle. So every nozzle has to be given a access. So how you gonna give access? Access means a person has to be there. In our case, suppose for example this nozzle, if I'm talking about this nozzle, so first of all you have to go to the distance. Now in the distance you have, see, if you bring your cursor here, you can see element, and this is graphics. So we are using these two only, and then you have a snap and a cursor. So element, snap, graphics and cursor, these are the combination to use. Okay, so whenever you want to pick a P point, whenever you want to pick a P point or a edge or a corner, then you will use graphics and cursor. But whenever you want to select a center point, you go with element and snap, this one. So now I need a P point. So I will click on graphics and cursor and then press the left mouse button and touch this. So from the top of this to the top of the grade level, top of the grade level, that is 1 lakh. So what is the distance? Height. It's 3100. So anyhow, as per our calculation, it is above 1.8 meters. So I need to provide a access here. So access means a person has to be here, his hand has to be here, or his body has to be here. So what we are going to do, we are going to create a platform at the top of this equipment. Okay, platform at the top of this equipment. Now there are two type of platform. One platform is resting on the equipment, means if we create a platform, it is going to weld on the equipment. That is a one first type of platform. Second type of platform is it is going to be rested or supported by the steel structure from the grade level. From the grade level they will raise a column like this, and from here also column like this, and then they will rest a platform at the top of the equipment. So that is the second case, and that is only used when the weight on the platform is too much. Now when the weight of the platform is going to increase, when the person is standing on the platform, so person weight will be there. Then if you have any big wall or any control wall assembly or any sort of assemblies, is you are keeping that assembly on top of the platform, then the weight of the platform is increased. In that situation, structural people will decide whether to give a permanent structure, or they will put a platform and weld it on the equipment. Now, when anyone is trying to weld a platform on the equipment, they have to discuss it with mechanical team, not the piping team. See, we will only provide, yeah, we will only give him a information about the platform length and the location. We are not involved in the calculation whether the equipment is gonna take the load of platform, or if not taken by the equipment, then they will go for the permanent structure for the platform. You got my point? But my job is to give the information about the location of the platform. So what I am going to do, I am going to create a equipment. Okay, so new equipment, name slash, now the platform name will be given with the equipment named as platform 1 2 3 4, like that. So v dash 1001 dash pltf dash 01, that's the equipment name. Correct. Now what I'm going to do is I'm going to create a box. So platform is like a box only. So new box, enter x length. Now x length and y length. X length will be the, now as you can see from this one, this axis. So this is east west. So x represent east. So this will be the length, x length. Okay. So x length will be always equals to the dia of the cylinder. So I will take 1600. Now you say it is not always, it depends. Suppose you need a half platform, you need a full platform, that will depend upon the routing and the arrangement. So for time being, always go with the dia of the equipment for time being. X length, then y length will be the length of the equipment, so that is 3000. And then z length, so the z length you can take it as 30 thickness. So the, see, if you talk, yeah, it's a platform thickness, so the platform thickness is 30 so so platform is like this, for example. uh how to explain you this? Okay, so there is a platform, okay, and it is like a, it is called grating, not platform. It is called grating. Yeah, you understood now? Yes, yes. Yeah, so this is a grating, right? So this grating has a thickness of 30 mm. Yeah, this grating has a thickness of 30 mm. So this 30 thickness, and below this, suppose if I see a side view, if I show you a side view, so it will be like this, and below this you will have a steel member, correct na, like this. So, yeah, so this thickness is, I am talking about 30 correct? So that's why I took a Z length of 30 Understood my point? So enter. So it will create at 000. Okay. Now if you now what you need to do, you have to bring this platform to here. Okay. So how you gonna bring? So click on the equipment, go to move position, then go to here origin only, click anywhere and click here anywhere. So it will come at the center of the equipment. Oh, I clicked somewhere else. Okay, wait. So move position. Oh, it's graphics cursor. So element. Yeah, click here and then click here and then apply. So it will come at the center of the equipment. So you know, now you know the height of the sorry, dia of the cylinder. So I will do by up how much, 800. You got my point? By up 800. Now the point is, always remember, see, now now this platform top should have a clearance of 150 from the bottom of the nozzle. This is very important things I'm telling you. Okay, so because this will, yeah, this will, yes, So this says, and from the bottom of this nozzle is this. So it you have to maintain a 150 mm clearance. Okay, so right now it's 261. So Q 150 minus 261, 1111. Correct. So these are the. So what you need to do is you have to go to the equipment and then you have to raise this by up 111 and WRT slash star enter. You got my point? Understood? There is any doubt till here? Okay, cool. So why I am putting this 150 mm cap, because there will be bolts. Okay, and even though you when you try to unscrew the bolts and nuts, so your hand will be at the bottom of this, so it should not, your hand should not scratch with the grating. So that's why we have a clearance. Now before this clearance, what clearance you needed at the bottom of this, so that is also near about 150 mm for safer side. So you have to cross check. So just take the bottom of this and the top of this. How much is it? It's 96 only. Max to max we can go for 100 mm. So still we don't have a minimum clearance here. Correct? Anyhow I need to move this platform little bit up. Okay, but before that do one thing. You have to find out the coordinate of this platform. See, whenever we are working in a project, always make sure that the coordinate should be in a round figure of 1000 or 500. So let me first check the coordinate of this platform. So designated point, and then I will go and select this point. So what is the up value? So up value is 2926. Either you can make this as 2950, either you can make this as 2950, or either you can make this as 3000. So when they calculate the top of platform or top of grating, the value should be round figure. So if I want to add here, like for example 3000 minus 2926, so 74 mm I need to move up. If I move 74 mm here, what will happen? This value will be reduced. This value will be reduced. So anyhow we have to, okay, so every time remember, in the project there is a maximum value and a minimum value. There is a maximum value and a minimum value. Correct. So for this project, as if I'm saying, like here we have to keep a 150 mm clearance, but that's a maximum value. Correct na? And a minimum value is 100 mm. So anyhow I need to move this one by up by 4 mm. So first let me move this one by up 4 mm. So by up 4 mm WRT slash star enter. So anyhow now I have a clearance of 100 mm minimum. Okay, now if I check, now if I go and check the position of this designated point, so what is the position? 2930. Okay, 2930. So if I move this one by 20 mm, what will happen? So here also 150 is the maximum, 100 is the minimum. Correct na? So I can move, yes. So we can move this by 20 mm, then the value will be round figure in terms of 50. So I just move this one by 20 mm. Enter. So now you can may think, so what is this distance from here to here? It's 126, still okay for me. And from here to here, it's 120. Okay, why it is 120? Oh yeah, yeah, okay, it's 120 because we are calculated from the bottom. So still we have like a margin. Okay, if it is 120, we can bring this down to 20. Na? Why we want? No, okay. No. Yes. Because we want a round figure value. So let it be like this. Okay. So both side we have 120, 120. It is manageable. So the platform elevation is fixed. Correct. So this is how you're gonna fix a platform at the top of the nozzle. Correct now. Now, now for example, uh, let us say I have a nozzle, one more nozzle at the top. Click on the equipment. Yeah. Click on the click. Now I will copy this nozzle to another side. So new nozzle, copy previous. Oops, sorry. New nozzle, copy previous by north. Let us say 2000 WRT slash turn enter. Okay, I have a what to say nozzle here and one nozzle is here. Okay, now if from both the nozzle I have a piping arrangement this side and I have a piping arrangement this side, correct? So what I will do, I will create a walkway in between this space and then we can access the thing, correct na? Similarly, if you have a nozzle and all the piping is it from this side only, then no need of putting a walkway, no need of putting the platform in this side. So that is called half platform. That is called half platform. So how does it look like? I will show you. Just double click of 2 3 times. Yeah. So you can see here. You can squeeze it like this, and you can bring it back to here. So this is your half platform. This is your half platform. So either you can go for this half platform or either you can go for a full platform. Okay, half platform is only used when you don't have to provide an access or any walkway here, or means like too many pipings are not here on the on top of the equipment, then you can go for halfway. Otherwise you will always go for a full way. Now the question is, whenever you you start your piping now, always create a full platform. Always. Never think of half platform. Always create a full platform. Okay. Okay, so let me bring it back. So 1600. Okay, now that's the biggest problem. Okay, so measure distance from this corner to this corner. How much? 400. So I will bring by east 400 WRT slash star enter. Yeah. So this is the platform elevation. How I set the platform elevation. Okay, now one more thing, whenever you do a piping whenever you do a piping here, sorry, whenever you do a piping, always remember the piping should be from the corner of the platform. You cannot run a piping from the center. Okay, always remember piping has to go like this and then go like this. So piping has to be from the corner of the or the from near to the edges of the platform, correct? Both the sides, understood? Okay, now one more thing, whenever you create a platform, you need to create a ladder also. What you need to create a ladder. Now ladder has to be come from the grade level, or it can be come from a intermediate also, but anyway ladder has to come from the grade level, because to reach here someone has to climb from the here. Okay, now what will happen? So in this particular, but for particularly this scenario, you have to create a ladder from the grade level. Now you need to decide from which side, either from this side or either from this side. So always remember whatever side you are piping. For example, if your piping it goes like this and it will goes down, so ladder has to be from the opposite side. Understood, na? So wherever you have a piping, your ladder has to be from the opposite end. Understood? Cool, na? So, in this particular scenario, I know all the piping has to be come from this side only. So I will provide a ladder this side, correct? Now, how to provide a ladder? So for providing a ladder, I will create a cylinder within this platform only. Okay. Now, why I'm creating ladder within inside this equipment or platform equipment? Because this ladder belongs to this platform only. That's why. Okay. So I will go and create a cylinder. So new silly enter and the height and dia. So always remember the cylinder dia will always be 800 mm. Okay, always remember the cylinder dia will be 800 mm. Now the height. Now height I have to calculate. I have to calculate means from the top of the grating to the top of the grade. So that is 3000. 3000 WRT star star enter. See, oh, why I put, sorry, yeah, like this. So it will create here. Hmm? Now what I need to do is, now for example, I want to bring the ladder from this edge. So I need to bring it here. So go to position, move, graphics, cursor, designated point. Yeah, it has to be like this. Now this is 800 mm. So I need to move this one by north 400 WRT slash star enter. Like, so this is how you're gonna create a ladder. Now this, now you have to make sure that the ladder should not clash with the equipment. Okay, ladder should not clash with the equipment, that you need to make sure. So you are going to do is, what you are going to do here is, okay, so you are going to create a plate inside this cylinder. Okay, so plate means it will be a box. So new box. Now x length will be the what, thickness. Yes, thickness. So thickness you can take it as 50, and y length will be the north and south, that will be your 800, that is equals to the diameter of the cylinder, and the z length will be 3000. Okay, so it is created here. So now I'm making a ladder here, so that just to identify whether the clash is going or not. So I just wanted to check. So again, move, position, graphics, cursor, designated position, select this corner point, and go and select this plate corner point. Okay, just move it, this one, and apply. So it will come here. Now see, uh, now can you see here, see the, just the edge. So basically ladder is not that much close to the platform, so it has to be little bit away from the platform. So that is 100 minimum. So by east 100 WRT slash star enter. Oh sorry, west, double click minus 100, and one more time if you do minus 100, so it will go outside. Yeah, so this is how your ladder is going to come. Okay, now one more thing. Now if you see here, your ladder is going to clash with this. Okay, so that is also not possible. That is also not possible. So you need to make sure that that this platform has to be come little bit outside. Okay, this platform has to become little bit outside. So for example, yeah, so click on it. Yeah, because you that you can adjust, that you can adjust. Okay, so I will give here a value of 3400 so it will 200 come outside, and this cylinder will goes 200 towards south. So by south 200 WRT slash star enter, and then this box also will be 200 so it is safe. It is safe now, and even though you can bring this by west 100 WRT slash star enter. Yeah, correct. So this will be at the center. So this is how you're gonna show the ladder. Okay, this is how you're gonna show the ladder. Okay, this is my ladder location, and from here I'm going to climb. So this is the first scenario. Now the second scenario is wherever you have a manhole. Wherever you have a manhole. Now first of all you have to measure what is the height of the manhole. So this is my manhole, and this is my height. So it's 2 meter. So as per the rule, above 1.8 we need to provide a platform. Okay, now for the manhole, what you need to do is, whenever you are creating a manhole and a platform for that manhole, the distance between the center of the manhole to the top of the grating has to be minimum 900 and maximum 1100 Okay, so that is very important point that you need to remember. uh, Distance between manhole and top of grating. Now this is important, top of grating. Okay, top of grating has to be minimum 900, minimum 900 and maximum 1100 mm. So that is another important point to consider. Okay, so for this platform, so this manual, I know that this center line of this manual is 2 meters, so it is one about 1.8 meters. So now let's make a platform. So again, we are going to make a new equipment. New equipment. Name of that equipment will be V dash 1001 dash PLTF dash 02, because this is a second platform. Okay, sometimes people will give the platform 1 and 2. Sometimes people will give the name of this platform as platform 2000. 2000 will be the elevation. Okay, so 2000 will be the elevation. So like that also we can give platform at 2000 level. The first platform will be at 3000 level, so people will give the name of 3000. Yeah, so as per the elevation you can also give the name. Okay. Hmm. And now suppose for example sometimes you have two platforms the same elevation, then you will give as platform 3000 slash 1. Okay, slash 1 slash 2, something like that. Understood na? Now it totally depends on your company philosophy. I'm just giving you a standard example. Okay, understood? Okay, now coming to this platform. So now I need a box. So new box. Again, you have to give the x length. So x length will be is equals to the dia of the cylinder. Y length will be the, okay, now this y length means if you are trying to create a platform here like this, so this will be the y length, right? This will be the y length. So what will be the y length? You will consider, always consider 1.2 meter. Okay, 1.2 meter always consider at the initial phase. Later on we can reduce it to 1 meter. Understood? Hmm. Hmm. So and z length will be your 30 mm grating height. Enter. So your now box is created here. Now just click on this equipment. Again go to move position, element snap. Origin is already selected. Click on this and click on this and apply. So it will come at the center of the, it will come at the center of the manhole. Now you just have to buy down 900 mm. Buy down 900. Always go with the 900 mm. Okay. So 900 mm is the height. Now before that you can see this is going inside. So what I need to do is first of all measure things. So what I told you, graphics cursor from the center line of the manhole to the top of the grating, it should be 900 mm. Right now it is 885. So you have to lower down the equipment by 15 mm. So by down 15 mm, WRT slash star enter. Oh, sorry, shit. By down 15 mm, correct? So this is how it will be correct, 900 mm from top of the grating to the center of this, and then you need to measure it from the center of the nozzle to the back side of this. How much is 600 mm? So you need to push this box outside towards south direction by 600 mm. So by south 600 WRT and slash star enter. So this is how you're gonna push it back, correct? So now you know that, okay, this is the position of my what platform. Understood? And then you need to again you need to provide a ladder. Okay, so already you are providing a ladder from this side, so again you will provide a ladder from this side only. Okay, try to keep a symmetry. Any doubt till here? Oh, clear na? Okay, so this is done, correct? Now again you have to create a same thing here also, same thing. Okay, now sometimes what happened, like here in the previous platform I created and like this. Now in this platform I will create in a different way, so you can create it as a sub equipment. So new sub equipment. Okay, and inside the sub equipment you can name this also, like the V dash 1001 dash PLTF dash 2000 dash L. L means for ladder, S for stairs. Okay, so L. So this is your sub equipment, and inside this sub equipment you can create a new box and cylinder. You got my point? So you have to create new cylinder, and the height will be like, for example, 2000. Dia will be always 800, and then enter. Oh, 2 by 2000. Sorry, not 2000. Okay, so what can I do here is, yes, 1100. I think so. 900. Yeah, 1100. So double click on this, remove this, and 1100. Enter. Okay, now you have to bring this one to this side. Yeah, position, move position, graphic cursor, designated position, and then select the top of this to the center of this, apply. It is somewhat here. So I know it is clashing, but you can do the modification. Yeah. So similarly, and you will create one more box and keeping a distance of 100 mm. So your ladder is created. Got my point? So this is how you're gonna create a platforms and giving access to every nozzle. Now one more thing. See, always remember, nothing should get obstructed. Okay, why I created this ladder here also, because I know that my all the piping will goes from this side, because we have a bottom nozzle also. The pipe will come out and then it will go like this. If you have a top nozzle, pipe will come out and drop it and then go like this. So anything happen, it will happen here only. It will happen here only. So that you need to understand. Okay, now one more thing is, right, like this equipment is placed here. So anyway, if you have a ladder here, so then there should be a access way, and the person has to walk here now. So you need to block this space. So how you gonna block it space? So again, you will create a new equipment. Okay, and then you have to give a name of that equipment as walkway. Then you have to give a name, that equipment name as walkway. Okay, so walkway is the name of that equipment. Now you have to create a box. So new box. Okay, now x length. X length is the east and west. So x length will always be, remember, 1.2 meter. Walkway width should be 1.2 meter. So x length will be your 1.2 meter. Now this is 1.2 meter. It works in onshore. Onshore. Okay, if it comes with offshore, na, so minimum is 700. Minimum is 700. Okay, maximum is 1 meter, but minimum is 700. Similarly, in the onshore, na, the maximum is 1.2 and the minimum is 800. Okay, so always take a maximum value. When you develop a layout, always take a maximum value. So x length will be 1.2, and then y length will be the length of the walkway that you needed. So for example, length of the walkway, I wanted it as 5 meter. Okay, and the z length. So that z length should be 2200 always, and enter. Once you enter this one here, what you need to do is you have to place this box at the corner of this grade level. So again, move position. Okay, before doing move position, always be on the equipment, then move position, designated point, graphics cursor, and select this corner point, and select this corner point, and then just apply. So this is how your this thing is coming. Now, yeah, now when you think like, okay, is this clashing with the equipment? Make sure it should not clash with the equipment, not with the ladder. But yeah, yes, correct, right. So this is how you're gonna make a walkway. Okay, now similarly you have to create a pipe. When you create a piping here, then you need to make a walkway for to access the walls and all. So let's start with the piping then. Okay, so this is all about your equipment, the modeling, the platforms, and the accessway operation, and all those things we consider here. Now, when we want to do the piping, so let's start with the piping. Okay, so piping is here. Okay, right click, rename P01 dash PIP piping, and apply. Yes, yeah. So area 01 piping is the here. Okay, inside this I'm going to create a piping for this. Okay, this particular nozzle, bottom nozzle. Okay, so just click a saver. Now for piping again, for piping we have a hierarchy, right? Hierarchy of piping is similarly to equipment like site, then you have zone, then you have pipe, then you have branch, and then you have component, right? Then you have component. Okay, so this is the same thing we are going to follow. So we already have site, we have zone, and inside zone we are going to do the piping. Okay, once you want to do the piping, you have to go and change it to piping discipline. So here you will get a new tab called piping. Okay, now if you want to create a pipe, you have option create pipe component, and if you want to modify, you have here some options are there. So we'll discuss one by one. So let us go to one zone and then just click on the pipe. Okay, create pipe. So before that, there is a piping name philosophy. There is a pipe name philosophy. Okay, so piping name philosophy depends on the project to project. So there is no first any philosophy is like a confirmed philosophy is given anywhere. So just I'm taking a random philosophy from my project only. So just 4 inch dash P dash 1500 dash A1A dash H. Okay. Now, what do you mean by here? And then dash A01. Okay. So, what do you mean by here is with this name philosophy? So, 4 is the size of the pipe. Okay. P is the process fluid of the pipe. 1500 is a unique line number. Okay. Yeah, line number. A1A is a piping spec. H is for insulation and A01 is a area number. Understood? So size, fluid code, unique line number, piping spec, insulation type, and area number. Got my point? So we are going to create a pipe here. So let's begin with that. So click on the create pipe. First of all, be on the piping department, then click on the pipe. You will have a new piping creation form open here. Now the same number that you created, you have to give here. Okay, so let us say I want to create. Now before that, I just wanted to check what is the size of this nozzle. Okay, so nozzle n2, and then I can check q para. So 101. Oops. Okay, so for that I will go to equipment, modify nozzle, and from here I can check what is the size. 100. Okay, fine. So be on the pipe again, and just it's 4 inch only. So I will type here 4 inch dash P dash 1500 dash A1A dash H dash A01. This is how you're gonna write the name. Correct. So this is the pipe name that you get. Now this pipe name philosophy is given in your PNID also. So what is given in the PNID, you have to take this exact same thing here, copy paste. Only the area number will be added by your own. You are the one who is going to add the area number because in PNID they don't have any area number, right? So area number will be added by you. Huh, huh. Hmm. Okay. So what I'm going to do here is now okay. From here now you need to check the spec. So let us go for this A1A spec, and here you have to decide the size. Okay, so here you have size of. Okay, why it's coming in this way? Okay, let's go for this 102 because it's 100 or it should be come in this, should not come in this way, but let me find out later. Okay, the insulation will be any whatever the insulation you have, so let us take K. Tracing will not be given. Temperature, okay, now this temperature is given in the insulation, sorry, no, line list. This temperature is given in the line list, so from there you have to select the temperature. Let us take 100, and this these two things are not required, so just simply apply. Once you click apply, see pipe and branch is already created. Pipe and branch is already created. Now what you need to do is here, be on the branch one. Okay, from here, now this is your branch head and this is your branch tail. Okay, so whenever you start a pipe, it has to be start from the head. So this is your head. Starting position is called head and the ending position is called tail. Okay, so today I'm just giving you an example of how the pipe is created. Then we will discuss piping very detailed, all these tools. Okay, so I just branch head. Now click on this cursor and click on the nozzle. So it is automatically your head starts from here. Okay, once your head is start, the pipe will automatically fetch the detail of nozzle. Now what are the detail of nozzle? It is fetching the size and the rating. The size and the rating means 4 inch and 150 rating, and this piping spec is also from 150 class. So whatever the component will come, it will come from 150 only. Hmm. Hmm. Ha, 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 ha. So similarly also same in the dumb model, you just have to click that nozzle. Once you click the nozzle, now it will automatically take the detail of the nozzle. Or it will take automatically. Okay, I will show you. I will show you. Okay. So once you clicked on this nozzle, head and tail is connected, then you can see here create components. Create components. So click on that. Okay, click on that. Once you click on this, what will happen? So this component form is open. Okay, so it has spec is given, bore is given, slope is answered, everything. Okay, insulation, tracing, everything is selected here already. Now, when you create the gasket, once you start the piping, the first component is coming as a gasket. So this is your gasket. Now inside the gasket, you have two options, 150 and 300. Okay, now how this 300 came? This 300 is for the out of spec flanges or are for a higher rating gasket. Okay, but for timing, we want only 150 and then just have to click create. So gasket is created here. Okay, similarly you have to create on the click on the flange, then you have to go to the weld neck flange of 150 rating and then you have to click on, just uncheck this and then click on create. So flange is created. Okay, yeah, this one now auto create. Auto create means what happen now, it will automatically create the gasket flange on top of this. So double it will double the thing. So that you we won't want, don't want. Okay, then click on the elbow, 90-degree elbow, click on create. Now see the elbow is created. Now if you want to give the angle to that, so you can do the angle. So you can have to go to modify and then you can give you the direction. So east, so it will turn, north, west, so it will rotate, na? South. So I want in east direction, so it will be in east. And if you want to give a spool to that, so click on this and then you have to give a spool like say 500 mm. So it will goes down 500 mm. Now if you want to give a 300, so double click on it and just change the value 300. So it will come to 300. Now if again elbow, okay. So elbow will be created here. So it will created here. Now you can rotate it, modify. Then direction will be towards north. It will rotate it. Then you want to give the spool 1 meter spool, so it will come outside, right? So this is now once the piping come outside here, always make sure that from the edge of the foundation to the edge of the pipe, this side, this one, minimum gap of 100 mm should be there, minimum. Right now it's 247, but I used to do the routing now, I will always consider 150 clear gap. How much? 150. So you also follow the same practice. Make sure a 150 clearance gap. So how much? Q 24 247.4 minus 150. So 97. So I have to move this elbow towards west by 97. So by west 97.4 WRT slash star enter. This is. So now it is 151 clear gap will be there. Now after this, suppose for example I want to put a wall. So I just put a flange, then gasket, then wall, 150 rating wall, then again gasket, then again flange. Okay, and then yeah, so this is much I want to create it. Okay, right. So now what I need to do here is, now I have a wall here, so definitely to operate this wall I need a walkway here. Correct na? I need a walkway here. So what I will do is I will copy this box and paste it to this side. So what I will do is, okay, now before that I will measure. So go to measure distance, graphic cursor, from this edge to this edge. From here till here, how much is the distance? 3334. Correct na? So I will copy this box. So new box, copy previous by is 3334 WRT slash star, enter. So I have a walkway here, and this walkway is not, it's slightly clashing because it is coming from the center of this. So you can move a little bit of 50 towards east, na? By east 50 WRT slash star, enter. Yeah. So this is how you gonna create a walkway when you do a piping here. So now this time, if you have any other equipment here, then again the piping will come goes like this, and then the equipment will be here. You got my mind? Hmm. So this is how a individual vessel or drum, but we will fix the piping and all that we'll learn later. Tomorrow, maybe tomorrow, yeah. So we will do the outlet piping, we will do the inlet piping, we will do the vent, we will do the PSV, and we will do the drain also. Okay, so this piping we will do in the later section of this drum piping. Yeah, you got it? Any doubt till here? Okay, you enjoyed? Okay, good. Yes, yes. Okay, good. Yeah. Ah, that we will discuss when we discuss the piping. Now, then we will discuss where to place the water at what elevation and all. Oh my God. Hmm. No problem, no problem. Okay, so we